Okay, so then what would that look like? Exactly. And then a longitudinal wave would look like how? I guess like this. Nothing's happening here. Oh. You gotta get the word first. So what? Like when it's more of them together, that's what this like is right here? Exactly. So the wave. So we got this in just to try to trigger. I have a third option that was to be This is actually like a combination. So what does this mean when it say parallel to the wave moving? So like it just stays. So think about this. All right. So you're looking at longitudinal wave, right? I'm pushing the wave that way, right? How are the particles moving? Which way are the particles traveling? Exactly. They're going in the same line that my wave is moving in. So that's parallel. Exactly. But in a transverse wave, I am. How's that perpendicular? Perpendicular is like when they think about it. So which way is the wave going? It's coming this way. Sorry, it's going. Yeah, it's going back and forth, so it's going that way, and it comes back. But it's moving left to right, right? But think about the individual rings of the slinky. How are they moving? In which direction are they moving as the slinky travels? The wave is traveling that way, but think about each ring. So they touching each other. So I want you to hold this out. Let me show you what I mean. So as the slinky is moving, each individual ring jumps out as the wave travels down.
Mr. Peterson.
As the wave travels, each thing pops out and then pops back in. And that's why it's perpendicular, because the wave is still traveling this way as a whole, but each ring is popping out and popping back. Whereas in a longitudinal wave, each wave is just pushing. Think about when we did it with the people. And at first we had our arms linked, and the person just pushed to the side, and everybody just pushed the next person to the side.
Where are you walking around to?
When we grabbed arms and one person stepped forward, what happened? The other people stepped forward.
Done.
Exactly. They popped out. Exactly. They popped out and popped out. Is that clear? That is so clear. I bet y'all get it. You see those? Alright, is that clear? Are you sure? Alright, tell me which type of wave is this?
On tap, let's go!
Why? Okay, it's moving. This is moving. This is moving. Why? What makes this? What about this movement makes it transverse? Yes, going in and out. So the particles, are they going parallel to the wave, or are they going perpendicular to the wave? What does parallel mean? They're not going straight. Okay, so they're moving around. So let's talk about the words parallel and perpendicular. Draw me two parallel lines. Take back to me. When you were on the paper, draw me two parallel lines. Okay, that's fine. Do you have a question to ask me? So take, instead of saying, I don't know,
Maybe you're learning it.
What does parallel mean? Oh my gosh, Aisha, I'm so glad that you asked. Parallel means going in the same direction. So think of it like this. Yeah, two parallel lines will be going at the same, they would have the same slope, they'd be going in the same direction. That's parallel. So then perpendicular lines are going in opposite directions. They cross at a right angle. So
7.8.
that's perpendicular. So you're right in describing the way that it was moving. That was a transverse wave. This is a transverse wave. The particles do move in a pop out a lot of ways, still going left to right. But that would be perpendicular. Parallel means that the wave, the particles are moving in the same direction as the wave, which is with our, what type of wave is this?
How much
Well, there are a lot of two waves.
Right.
Yeah, longitudinal, transverse. All right, I'm gonna leave you alone for that so you move on, and I'm gonna come back and